Hello, fabulous fifth graders from Miss Saw, Miss Matamore's class. You should have already watched the video with Mr. Haubecker for lesson 5, module 5. And he was showing you that 1 cubic centimeter. That's very similar to think of it as like one little ice cube. And when that ice cube melts, it becomes exactly 1 milliliter. So 1 centimeter cubed or 1 cubic centimeter automatically becomes 1 milliliter. Okay. So he already did number 1 with you, and he already did number 2 with you. He did part A with you, and yes, there would be enough room to put 250 milliliters in there. It can hold 864 milliliters, so technically you will actually have enough space to fit another 614 milliliters in there. That's a huge box. That's how much more space they would actually have for that one. This one can only hold 240 milliliters, so that means 10 milliliters would actually pour out onto the ground. You'd actually have a puddle here of 10 milliliters if you try to pour all 250 milliliters into part B. All right, part C, if we look at part C is this little one up here, so let me zoom in a little bit for you guys. So part C, if you had the volume equals length times width times height. So the length is 25, the width is 5. So 25 times 5 times 2, this height right here is 2. Think of it as like a big, long, not very deep, like brownie pan. So 25 times 5, or actually 5 times 2 is 10, so that should be 250 centimeters, which would also be 250 milliliters, so that yes, this would fit, and it would fit exactly. It would fit exactly to the brim. The brim is the very tippy top without it falling out over onto the ground. So C would definitely fit it. Let's go right here to E. So on E, they gave you the base area, or the base face. So they said that that's 75 centimeters squared, and we know we have 3 of them. So if I were to split this up into three layers, this first layer would be 75 centimeters squared. The second layer would be 75 centimeters squared. The third layer would be 75 centimeters squared. So if I did volume equals length times width times height, I know my height right here is 3 centimeters. And I know my length and width times together would be 75 centimeters. So 75 times 3 would be 225 centimeters. So yes, this one would definitely work. Or I'm sorry, no, this one would not work because it would only hold 225 centimeters. And you need it to hold 250 milliliters. So 225 centimeters cubed would only hold 225 milliliters. So if I took 250 and I subtracted 225 for it, you'd have overflow of 25 milliliters. That means you'd pour all this water into here, and then 25 milliliters would pour out onto the ground because this container is not big enough. And then this very last one, we seem to be missing a measurement on it. It seems like they cut off that this side right here is 15. So make sure you write that side in. Now, if that side is 15, you have a volume that equals length times width times height. And if you look at length times width, that would be 5 times 3 times 15. 5 times 3 is 15 times 15, which should equal 225 centimeters cubed, which is the same as 225 milliliters, and that's the same as this one, 225 milliliters. So we again know that this will not work. You will end up having a puddle over here of 25 milliliters. They will not fit. It will overflow. Think of it as like a fish tank. You pour 250 milliliters in, and it's going to overflow onto the ground by 25. And then problem 3, Mr. Haubecker did for you, and I tried to scratch it out real fast because I didn't have a computer. But I just wanted to show you, like if you zoom in on the beaker, you have to count these lines and see what you're counting by. Excuse me. So from 70 to 80, if there's these little hash marks, are you counting 1, 2, 3, 4, 5, 6, 7, 8, 9? So 71, 72, 73, 74, 75, 76, 77, 78, 79, 80. Okay, so each of these little dash marks we're counting by ones. They may have beakers that are counting by 5s. They may have beakers that are counting, or graduated cylinders that are counting by 2s. So always check to see what you're counting by before you mark it. So again, they just asked you to color it in. This beaker was counting by tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And 100 milliliters would be just up to here. Okay. Now we're going to head to the problem set. Thanks so much, guys. So again, on problem 2, only boxes A and C could hold 250 milliliters. The other ones are all too small. Thank you.